How you guys doing? We are going to be doing something now that I said I would do a long time ago, but then I got backed up with a bunch of other requests and didn't get to. So, recently, I believe either earlier this year or late last year, I assume it was earlier this year, the OEMC, which was then called the OEMC, held a competition. It was the winter competition. It had multiple types. The individual test was one of them. I announced it here on the channel, and I guess it went really well. This was put together, it was originally called this, again now this, which stands for the OYMC is the Online Youth Mathematics Competition, not to be confused with the OYMCA, which is actually nothing, I just made it up. Anyways, this was the individual problem number 21. I'm going to be doing 21 through 24 in this video. I decided not to do 25. I just felt like it was one I didn't really want to try to explain. And so there's 25 questions on the individual round. They are free response. It is not multiple choice. The team that works for this, the founder is Jason Shea. There is a co-founder, Emily Liu. I think I'm pronouncing that correctly. I hope so. And there's several other, there's a really talented team behind this contest. Like, they've got multiple accolades, more than I've gotten. So they're really good. It's probably very much worth doing. And so this is an announcement as well about their upcoming summer competition. Currently, and these dates are subject to change, the elementary contest is being held on July 17th, and the middle school contest is being held on July 24th. And so the item writers are all, multiply very well qualified individuals. And so desirable prizes, these are good because, well, they're not undesirable prizes, which nobody really wants. You actually want these prizes. What are some of the prizes you can get? You could win a free hour of private tutoring with moi. Okay, and so those are available. There's many other prizes, probably better than that one. On the website, I'm going to link their website right down here in the description, or somewhere where you click, I don't know, or down here, read more, something. There's a description somewhere on this video, and you can click it. There'll be a link to take you to the OYMC website. And the last thing I want to mention is I really like helping good people, and these are good people. I can just tell, I get the sense with interactions with Jason, that this is a good organization. It's up and coming. It's run by students currently. And that's just great. You want to support those things. You need more practice. Get more practice at every competition that you can get your hands on. I have no idea if there's a fee. I believe it's free, but don't quote me on that. I don't know. You'll have to check their website out to see how it works. Again, these dates, subject to change. Tentatively put it in your calendar. What were you going to do on these dates anyway? Stay home? Yeah, you probably were. So anyways, why don't you do the competition instead? You have this trip to Disneyland you could have gone on. Come on, do you really want to go to Disneyland? Obviously, you want to take the OYMC. Okay, so that's coming up. That's what's going on. Let's get to problem 21. How many solutions does all of this have? My first thought when I looked at it, honestly, was to call this u squared. Just u for x minus 3, and then this would be u minus 1, u minus 2, u plus 1, and u plus 2. It's plus 2 because you're subtracting less. And I thought about doing that, and then I thought about, oh, it's equal to 0. Wait a minute, these are all like quadratics, kind of. They're parabolas, right? But you should know that when you square something, the smallest value that it can take on is 0. It can never be negative. Well, let's see. Can you even square imaginary numbers and get a negative? I think you probably could. I don't know. I can't think off the top of my head. But if a real number system, right, you can only get 0 as your smallest value. How would I get 0 here? I'd have to put 2 in. But how would I get 0 here? I'd have to put 1 in, and then you realize that there's no way this is going to work, is it? And that's why the answer is 0. There's no way that you can find a number that makes all of these perfect squares 0. And the moment one of them is not, if this is not a 2, this value will not be 0. It will be positive. And if you have a positive value plus, even if these were somehow all zeros, you would not be able to equal 0. There's no solution to this problem. Let's get on to the next one. All right, continuing on with the 2021 OEMC, now OYMC, winter individual problem number 22. What is the greatest two-digit integer with 8 factors? Okay, so the first thing I want to think of is, how do we know how many factors a number has? You might not know this. It's an early number theory topic, but you don't always get into number theory when you're in middle school or elementary or whatnot right away. So if you don't know, it has to do with the prime factorization. For example, if I take the number 60, this is 4 times 15, which we can say is 2 squared times 3 times 5. And these are both to the first power. Okay, so then what? All you're going to do is take the exponent and add 1. So if I add 1 to this 2, I get 3. If I add 1 to this 1, I get 2, and 1 to this 1, I get 2. And as you might have guessed, you will multiply this out, because that's what these little dots mean. They mean multiply. 3 times 4 is 12. Now, we can also just list them out. Sure, that's not bad. You could do 60 and 1, right? 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Look, there's 12, just like we said. But listing takes longer. And so if it was a big number or an unknown number, you can't always list, or it's prohibitively difficult or time consuming or something we just don't want to do. Because this is cooler. All right, so why does this work? Well, it's actually based on the fundamental counting principle. The fundamental counting principle says that if one event can occur in m ways and another event can occur in n ways, and the first event doesn't affect the second, you will get m times n ways. For example, the one I always use, if you have 3 pairs of pants and 4 shirts, you have 12 outfits, right? 3 times 4 is 12. That's the fundamental counting principle. So how is this the fundamental counting principle? Well, easy. You're making 3 choices between your prime powers that you will use. You can either use 2 to the 0, 2 to the first, or 2 to the second. You can use 3 to the 0 or 3 to the first, and 5 to the 0 or 5 to the first. Each of these choices is independent. They don't affect the other one. It's not like because you chose 2 to the first, your finger or your mind is drawn to the 3 to the first more than the 3 to the 0. No, you can choose whatever you want, right? So it doesn't affect, there are 3 choices here, that's this 3, 2 choices here, 2 choices here. Okay, so let's get to how that applies to this problem. We want a 2-digit integer with 8 factors. The first option is p to the 7th. P, Q are commonly used for prime number problems like this one, and R if you need it. Another way you could do, because you would add 1 to this to get 8. The other one you could do is if you wanted to do 4 times 2 is 8. That would be p to the 3rd times q to the 1st, because this becomes the 4, this becomes the 2. Okay, but there's still one more possibility, p to the 1st times q to the 1st times r to the 1st, because 2 times 2 times 2 is also 8. And there could be 3 prime factors. So we first try this one. But how do you evaluate if it's possibly p to the 7th? Pick the smallest prime. If you didn't know, 1's not prime. It's not. Whoever told you that, if you ever heard it from somebody else, they're wrong. Okay, but 2 is prime. It is the only even prime. In fact, those are the first 2 rules of primes I teach students. Number 1, 1 is not prime. It has to have 2 distinct factors, 1 and itself. Okay, so 2 is the first prime. It is the only even prime. If you put 2 to the 7th here, you're going to get 128, which last time I checked is not 2. That's 3, not, yeah, no. Not going to work. No, we got that one. This one could work. Again, probably if you use 3 to the 3rd, you would have 27. Times 2 would be 54. Times 5, you're going over 3 digits. So 54 is possible right now. If you tried 5 to the 3rd, it's too big. So the natural thing to do is to put the 2 into the p's position. 2 to the 3rd is 8. Then what do I want to use here? You want to use the biggest prime that will not take you over 2 digits. So if I do 11, I get 88. This looks pretty good, but is it the answer? We don't know yet. We got to keep going. What about, say, 8 times 13? Well, 8 times 13 is 3 digits, so that's not going to work because 80 plus 24, 104, right? Yeah, that's 8 times 13, right? 104? I think that's right. 80, 12, 96. 96 plus 8. Yeah, 104. Okay, I just had a double, triple check there. Okay, you should be doing that too when you're solving, by the way. Second guess yourself a lot, because a lot of times your initial instinct, it's most of the time right, but I'm sure you're familiar with the times that it's not right. Okay, then how about this one? We could do 2 times 3 times 5. That would only be 30. We could do 2 times 3 times, let's go as high as we can. 17. 6 times 17 is 102. Thanks, AMC 10, because if you get 17 right, you get 102 points, because there's 6 points per question. So that's too big, but what if we went down to 13? 15's not prime. 6 times 13 is 78. That's less than 88 last time I checked. And that's not going to work. So we keep making adjustments. We try 2 times 5 times 13. 10 times 13 is too big. 10 times 11 is too big. Have to go all the way down to 7 to get 70. That's not going to work. 2 times 7 times something larger. That's going to be 14 times, even if you went to 11, the next available prime, it wouldn't work. I'm trying to be systematic in keeping a 2 involved, okay? So we did 2 times 3 times every combo we could think of. We then tried 2 times 5 times a larger prime. It's a system, right? It's organized. You're not just randomly guessing, okay? Then up next would be, you can't do anything else with 2s, basically, at this point. So you have to do 3 times, and if you do 3 times 5 times 7, the 3 smallest primes that don't include 2, you're going to get 105. That doesn't work. That means 88 is it. That is the greatest 2-digit integer with 8 factors. Let's do the next one. And continuing on with the 2021, it was then called OEMC. It's now called the OYMC Winter Invitational Problem 23. By the way, just quick mention, on their website, when you check it out, it's actually a good-looking website. It loads quickly. Whoever made that, good job. Let there be an equilateral triangle ABC. Inscribe circle O in ABC. Okay, so we're going to have to do stuff. There's no picture given. Start making it. Don't keep reading the whole thing, right? It's going to be harder to do otherwise. So we'll make what looks somewhat, hopefully, like an equilateral triangle. Maybe that looks more isosceles. Maybe that doesn't even look right. Let's draw it straight on. I'm trying not to block the camera, but it's going to be a lot harder to draw it properly if I don't go straight on for this one. Okay, that's a lot closer to equilateral than the first one. All right, next up, circle O. We're inscribing it in the triangle. Inscribed means it will hit all the sides. Okay, let's draw that kind of straight on 2. And let's erase the starter part of the circle. Okay, so ABC such that circle O is tangent to all 3 sides. Okay. Construct altitude AD of ABC. Now that altitude, this is called the inscribed circle, or the in circle, and its center will lie on this altitude. How do you know this? Geometry. Take geometry, guys. Or preview it somehow. Khan Academy, maybe? I don't know. There's lots of things you can do to self-learn geometry. Do not say to yourself, well, I haven't learned that in school yet. That's too bad. Figure it out, man. You guys gotta get with it. You gotta get ahead, okay? So don't wait till you learn it in school. Don't let the constructs of the world designed to educate you hold back your progress. Okay, look up things on your own. Be inquisitive. Be curious. Aim to get ahead. So then from here, this is R, and this would be R as well, and they're calling this a circle O. They're saying that, what does it say? Segment AD intersects circle O at 2 points, which are D and E. So A's up here, if you can't tell. I'll call this B and C. D would be down here. How do we know D's down there? It's altitude AD. Altitude means it's perpendicular to the base, right here, okay? And what else? Oh, this is E, right here. So we got E going on, and what's next? If AE is 1, so we know that this is 1 right here, then the length of AB, that's the side length of the original triangle, can be expressed as A root B, such that A is not 1 and B isn't divisible by the square of any prime. In other words, it's simplified. And while it's simplified, A does not equal 1. What is a plus b? Okay, so in other words, the sum of these two values once you get the side length of it written that way. The main thing about this is you need to know that if you connect the center to the point of tangency, any circle, when you have a line tangent to it, your very first thought should be 90 degrees. It is perpendicular, 90 degrees. Instantaneous, okay? That's your goal. You might not know that yet. That's why I'm telling you, so that in the future when you see this in math competitions, you will know the first thought that you should have to explore that. In other words, this is going to be 90 right here, and we know that this length is r. Furthermore, because it was an equilateral triangle, I'm going to call this F right here. So I've got AFO, a right triangle. We'll go this way, I guess, to draw it separate so we can see it a little bit. A being here, F being here, O being here. Now this side is r plus 1, but this altitude is a bisector of the angle BAC, which means it cuts it in half. And since it was originally 60, this will be 30. Okay, since that's 30 and this is 90, this is forced to be 60. And if you haven't learned about 30, 60, 90 triangles, they are a staple in math competitions. You definitely want to learn them and be quick to be able to act upon them. So how do they work? I will quickly point out how they work. I'm not going to develop this for you. It is fully developed in Art of Problem Solving's geometry book, amongst other places. You are welcome to pick up that book. I will link it in the description as well. So in a 30, 60, 90, the opposite of 30, I usually call it x. What's opposite 60 is x root 3, and opposite 90 is 2x. You should know that 2 is greater than root 3. And if you know that, the biggest angle gets the biggest side opposite. That's true for all triangles. Okay? I like to say that they're as easy as 1, 2, 3. The 30, 60, 90 triangles are as easy as 1, 2, 3. Slap a square root on that one, attach an x, and you have 1x, 2x, and x root 3, the side lengths of the equilateral triangle. And so then, because this is 30 and opposite is r, we can look what's opposite 60 is r root 3, which is this, r root 3. Keep in mind that's this length right here, and this is going to be a midpoint of that side. So this will be r root 3 as well, and r root 3. The only way you can inscribe a circle in an equilateral triangle is that this would also, for instance, be a median and an altitude, and as a median it will hit the midpoint. For an equilateral triangle, all of the key points of concurrency for medians, altitudes, angle bisectors, perpendicular bisectors are all the same point. This is the incenter, it is the orthocenter, it is the centroid. And if you don't know what all those things mean, that's okay. You can go look them up in the future. I don't have time in this video to break them all down, but they are called points of concurrency for triangles. You can use that as a starting point in your search engine of choice and get started on that. So up next we've got this. Now what? Well, this doesn't say 2x, it should be 2r. So because of that, we can just do Pythagorean, right? Why is it r plus 1? This is r, AE was 1. So Pythagorean should work here. Oh, you know what? We should be able to get it right now. We know that this should be equal to 2r. I was going to do Pythagorean. And actually that's the way I did it when I solved it on my own. But right now on the board while I'm talking to you, I thought, why did I do Pythagorean? For if you don't know, Pythagorean would be the r root 3 side squared plus the r squared equals r plus 1 squared. And it works. It does give you the same answer. But why would I do that when I can use 30, 60, 90, move the r over? 1 is equal to r. So this is 1 root 3. Is that a problem? It said a was not 1. No, because this is not the side length of AB. AB is the whole side. It's twice that. It's 2 root 3. And then it asks us, what is the sum of these two values? 3 cannot be simplified. It can't inside of the square root. The sum is 2 plus 3 equals 5. This problem and the one right after were my favorite problems that I did of this contest. Really well designed. This is right up the alley of a very difficult elementary or middle school problem for advanced students. Whoever designed this, well done. All right, for the final problem of this set that I decided to do, again, I decided to do this for the announcement of the upcoming OEMC summer contest. It's at the beginning of the video if you didn't hear the dates. This was their former name, OEMC. This was their winter contest, I assume earlier this year because it was 2021. And this was the individual round problem 24. This one and the previous one, I only did these 4 problems. I thought these 2 were really well designed. This is a great combo question. It is advanced difficulty for novice solvers. And so if you're obviously experienced, you can get through this pretty quickly. It'd be trivial for you. But most students in middle school don't have that massive data bank of experience to draw from. And this is really good. It's going to teach them, right? Sometimes not getting something right is good for you and not knowing how. Why? Because it pushes you to learn the underlying mechanics by which you would get it right in the future. Don't be ashamed of your mistakes. Capitalize on them. Learn, right? If things you don't know, not a reason to be demoralized. It's a reason to learn. Okay, so a group of 8 girls are very picky about their group picture. Angelina must sit next to her best friend Bella. I mean, they're inseparable. She cannot sit by anyone else, but she can because they're going to be in a circle. But she has to sit next to Bella. All right, she'll have a fit otherwise. But meanwhile, Emily refuses to sit next to Francesca after she had that Instagram post that she talked bad about Emily. No, I'm not going to sit next to her anymore. All right, so I'm making that up. That's not part of the problem. They are sitting in a circle. You have to kind of add some to the story, right? Embellish it a little bit. Makes it more interesting. They are sitting in a circle. How many ways can they be placed? 2 seatings are considered equivalent if one is a rotation of the other. There should be a period. Good. Okay, the first thing is there's something called circular permutations. And for people in a circle, if there's 8, it would simply become 7 factorial. And the reason is, if you were to arrange, let's just take 4 people, 1, 2, 3, 4, right? If you had A, B, C, D, normally if they were in a line, it would be 4 factorial if you had them arranged in a line. But since it's in a circle and I can rotate this in 4 ways to place A in any of the original 4 positions, you divide to get 3 factorial, which is just 1 less factorial than the number of people. Okay, so we are going to start with that as our premise of what we're going to do. If we have this circle again, you don't have to draw, you don't have to put 8 spaces. We're just going to put A and B together in a group, and my notation for that is this parenthesis. They're going to be together. There's going to be C, D, E, F, where are we at? 6, G, H, and you got Emily and Francesca. They hate each other or despise each other or something, right? Anyways, that would be 8, but we don't want them together. How are we going to do that? Well, let's just forget about it for now. Sometimes when you're stuck on things, you can worry about that part later. Let's count this as if Emily and Francesca don't care if they sit by each other. How would I do this? Well, this is going to count as 1 person with 2 arrangements. Okay? So the 1 person means that there's now 7 people here. Originally there was 8, but this is a group of people that counts as 1. They're like inseparable. So now there's considered 7 people. So for that circular permutations trick, you're going to have 6 factorial. However, A and B have 2 arrangements. They have 2 arrangements, so you're going to get 2 times 6 factorial. Great. Well, if that's all the ways it would work, if Emily and Francesca didn't despise each other, how do we resolve it considering that they do? We're going to need to separate them. So all we're going to do is subtract out all the cases that we don't want, the ones where F and E are together. So we will subtract. Now, if we put them as a group, now you would have 6 people, even though these count as like 1 person each with 2 arrangements each. So those 6 people would have 5 factorial circular permutations, and each of these would have 2 arrangements. So we're going to have 2 times 2 times 5 factorial. This is called complementary counting if you want to look for more things to practice. 6 factorial, you might not know what that is. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. That's how all factorials work. The exclamation point is the factorial, F-A-C-T-O-R-I-A-L. And you can stop writing them at any point, like 6 times 5 factorial, and just finish with the factorial. So I can take a 5 factorial out of both of these terms along with the 2, and that's exactly what I'm going to do. That's going to leave a 6 minus 2 behind. This makes 4 times 2 is 8. You don't have to memorize your factorials, but you should. At least the early ones. 5 factorial is 120. Okay, so 20 times 6, 120. 8 times 120 is 8 times 12 with a 0, 96. Attach the 0, get 960, win a prize. That is it for this session, guys. I hope you enjoyed it. Be sure to check out their contest if you are in elementary or middle school. The sign up is on their website. You can read all about who they are, their creation, their past problems with the solutions written. I will see you guys in the next video.